Hello guys, welcome to IT Techie. So today we will going to see what is Docker and the respected theory. Okay, so let's start now. So Docker is an open source containerization platform, right? Docker enable developer to package the application into a containers, standardized executable component that combine the application source code with all operating system and their libraries and the dependencies required to run the code in any environment. So what exactly it is saying? It is saying that for running any application, what is required? We require the source code for running the applications, we require the operating system, we require libraries, and we require the dependency. So for combining all those things, it will convert it into a package, and that out of that package we will prepare the images, and out of that images we will create the containers. So that is what it's saying. For running any application, what is required? We require source code, we require operating system, we require libraries, and we require the dependency. That is what it is saying. So now second, what it is saying, images can exist without containers. So what it's saying, images can exist without container, whereas container needs to run an image to exist. Therefore containers are dependent on the image, but image is not dependent on the container. That is what it is saying. The two concepts exist as essential component rather than essential component in the process of running a Docker container. So now virtualization is the technology which can simulate your physical hardware such as CPU, cores, memory, disks, and represent it as a separate machine. It has its own guest OS, kernel, process, drivers. Therefore, it is hardware level virtualization. Most common technology is VMware and VirtualBox. So what it is saying, that VirtualBox basically VM, we can say, is like it will work like a VM. So by using the hypervisor, what we can do, we can divide the hardware resources, and for example we have a one 500 GB hard disk, we have a 8 GB RAM, and then so if I want to share this 500 GB into 100 GB, we can allocate to a one OS, then 100 GB I allocated to a different OS. So like that we can share that resources, and once we share that resources, we can deploy that application to the respective VM. So each machine we can uh, deploy the application and we can run it. So now what is the next step? Containerization is OS level or virtualization. It doesn't simulate the entire physical machine, it just simulates the OS of your machine, correct? So what as perspective of containerization, now there are multiple containers which will run uh, on OS level virtualizations, right? So what it means basically, multiple container, it will share the host OS. So I will represent it properly in the next topic. You can see, so it does not simulate the physical machine, it just simulate the OS of your machine. Therefore multiple application can share the same OS kernel. Container play a similar role to a virtual machine, but without hardware virtualization. Most common container technology is Docker. So what it is, Docker daemon is basically the thing is where you are installing the Docker. So I will for 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 uh, uh, for this picture perspective, I will explain you all those things. So you can see what is the question where it is raised, that is what is virtualization. So let me explain that. Virtualization basically, by using that hypervisor, we will divide the machine into a different OS. So one machine we can install the Ubuntu, we can install the Windows, or we can install the Linux. So like that we can install by using the hypervisor. Okay, so this is called as a VM. Okay, and as a container perspective, in the containers perspective, what it will happen, the respective libraries and dependency, and what we need to do, we have to just manage the libraries, binaries, and the application source code. Remaining thing, that all the containers will share the hard disks and other things, it will share the host OS. It means where you have installed your container, I mean Docker engine, that will utilize the that will share the OS with all container, will share the same OS. Okay, but here we have a separate OS for all the VMs. This is VM1, this is VM2, this is VM3, right? So like that, I have taken the example here. You can see, as a hypervisor, we have a one machine we have installed the Java application, another machine we have installed the we are running the Python application, and another one is the Node.js. You can see VM1, VM2, and VM3. How we are dividing it by using the hypervisor. You can see. Now in case of the Docker, how exactly it is happening. So in the Docker, we are creating a multiple container. So each container we have a Java. application. Each one container is a Java application, another one is a Python application, another one is a Node.js. But it is sharing the same OS, guys. In the Docker perspective, we are sharing the same OS, but in case of hypervisor, we are divided that OS, and we are allocated some resources to a different OS. Okay, so one OS we will allocate 100 GB, another OS we can allocate 200 GB, something we can do it here. But in case of Docker, the where you install the Docker, the same host machine will be share the OS to all our containers. Clear it? Now this is the differentiation between the virtualization and containerization. So virtualization is the technology which can simulate your physical hardware, same as I explained. Containerization is OS level virtualization, as I said, because we are sharing the same OS for all the containers. It does not simulate the entire physical machine, because each container we do not have a separate OS, right? So same OS only we are sharing it. Detaching layer. So it is used hypervisor to detach the physical machines, right? Here it is saying, you can see this hypervisor is divided into a different OS. Application 1, application 2, and application 3. All application have a different OS. You can see, guys. So same point it is covering here. It is used hypervisor to detach the physical machine. It is used Docker engine in case of Docker, correct? It has hardware level isolation, so if it is fully secured, you can see it is hardware level association, right? Because each machine have a different configurations and different application we can deploy it. It is a process level isolation, because container is nothing but what? It's a process. We are isolating that container. It will work each container like a service or like a process. It is heavyweight, because you can see, guys, virtualization is very heavyweight here. So because it is installed the OS, then binary, then libraries, and then application. But in case of here Docker, you can see each container have required only a dependency, libraries, and application, and it is sharing the same host OS only, right? That is what it is saying. It is heavyweight and it is lightweight. Now it is not portable, right? You can see, guys, this one we cannot move anywhere. These configurations, hardware lower configuration, we cannot move anywhere, so it is not portable. The same point I am covering now. And it is saying it is very portable, we can build, ship, and run anywhere. That is what Docker we can call it as a, we can build, ship, and run anywhere. So same, what is virtualization? Virtualization is the process of creating the software based virtual version of something, compute, storage, server, and application. This virtual version or environment are created from a single physical hardware machine, right? Because in a single physical hardware machine, on top of that we will install the hypervisor, and then we are dividing the machines, right? Virtualization lets you split one system into a different section which act like a separate distinct individual system. A software called hypervisor makes this kind of splitting possible. The virtual environment created by the hypervisor is called as virtual machine. That is what I am saying. So here is a virtual environment it will create it, right? By using the hypervisor, this OS1 application 1 cannot able to communicate with app 2, right? Because they don't know what is going on in a different machines. So by how it is possible? Because all application is running on the same machines, but due to hypervisor they are not communicate with each other. Okay, that is what the point is saying. The virtual environment created by hypervisor is called as virtual machine. Now let's move on to containerization. What is containerization? Let me explain this with an example. Now you can see, guys, usually in the software development process, code developed on one machine might not work perfectly fine on any other machine, because of the, if you are working, guys, then you comes to know that if your code is working in your local system, it may or may not be, it will work in a higher environment, right? That is what is saying. What is the reason behind that? The reason behind that, we are using different version of dependency or libraries. Due to that, it is may or may not be work on a higher environment, right? So this problem was solved by the containerization platform, right? This problem was solved by containerization concept. So basically an application that is being developed and deployed is bundled and wrapped together into and wrapped together with all its configuration files and dependency. This bundle is called as a container. So you can see, guys, in the, for running the container application, what is required? We require the Tomcat. We will include in the package, what we will include in the package? We will include OS library small, Java, Tomcat, and then var file. So once you package out of this, everything it is there for running one application. All thing is required. For what we required, application source code called as var file or er files, whatever it may be. And what is we required? Application server called as Tomcat. And what technology we are using? Java code. And what OS we are? This OS is communicate with this OS. Okay. So like that, for once we package this, then it will run anywhere. So out of this package we will prepare the image, and that image, from that image we will create the containers. Okay. Now when you wish to run the application on another system, the container is deployed, which will give a bug free environment, as all the dependency and libraries are wrapped together. As I said earlier, the same thing is explaining here. Most famous containerization environment are Docker and Kubernetes. Okay. Now how exactly happen? Okay, you can see the Docker architectures. Now Docker architectures, you can see we have one layer is client, another one is Docker host, and another one is registry. So Docker client means what exactly, guys? Where we are executing our command called as putty console or terminal, we can say. Okay, so that is called as a client, because with that client through we are able to communicate with the Docker host. Correct. This client is communicate with this Docker host. What is Docker host, guys? The Docker host means where you are install your Docker software in the machines. So this, by using this putty, we will communicate with Docker host. Under Docker host, what will be there? Docker daemon. Docker daemon is nothing but a Docker machine. Okay. And what is this registry? Registry means is our repository where we are pushing or pulling the images, right? Hope. So these are the Docker build, Docker pull, Docker run command we are executing normally to communicate with the Docker host. What is saying? This all architecture. So if you like this video, please like, share, and subscribe my channel. Next topic we will cover in the next video. Thank you.